I've got a set of mud guards here off of a John Deere 6125M. They've been dropped off by a customer for some repairs. Now I know mud guards might not sound very interesting, but these ones are a little bit trick. When the tractor goes around the corner, the whole wheel arch moves with the wheel, but then once it gets to nearly full lock, the wheel arch hits the side of the body. Now that would normally be a problem, but these, the body actually pushes the wheel arch out of the way. Now, as you can see, this one is a bit knackered. And then there's a couple of other repairs need doing as well. Come on. So first things first, let's get this taken to bits. Come on, there we go. Yeah, that's got a good wobble, that has. Ooh, okay. Yeah, that's moving. There we go. So here's the dust seal, just a metal piece that's been pressed into the casting, and then here I'll just flex it so you can see there's the rubber seal that goes around the bottom. Then there's a little notch there for this end of the spring, and then the spring's wound around this shaft, and then there's another tab on the other end of the spring that goes into this keyway. I'm hoping that this face here and this shaft are hardened and they're to size, and that all the wear is in the cap. If we have a look down here, you can see these marks. These are actually raised up from the surface. So this is where, when this has been rotating around, these grease grooves here, this has all been bashing around in there, and the material that's actually left is those raised bits. So all these bits here, this bit here and this bit here, has all been knocked back, and then these bits here are what's sort of been left and not been hit because it's been sat in those grease grooves on the other part. At least I think that's what's happened. So I reckon we'll probably need to machine this out, drop a sleeve in there, and then I wouldn't be surprised if we also need to machine the top out and drop a sleeve in there as well. You can just see, just here, it's the same evidence, same damage, so we'll need to sleeve the top and sleeve the bottom. We're definitely going to have to do some machining on this, so let's get all the bits out that could get damaged, full of swarf, etc., or just generally in the way. Just grease nipple. I'll get this seal out as well. There we go. Let's just take this off. Oh, that was easier than expected. You have to just be very careful putting that back on. This is a really fragile edge. No, that's not. Come on. Oh, right, there we go. The old get your feet off the floor trick seems to have worked. Great. So this has got some locking teeth so you can position it and then do it with the bolt, locks it in place, and I put a mark on here all the way across so that when we put it back together, you know, I can just line the marks up, drop the bolt back in, and it's in the right place. Let's find out if this piece is hard. Just give it a quick run with a file. Okay, yeah, that's skating across the surface, so that's pretty hard. That's good. Oh yeah, that's soft as butter, that is. That's cutting in, no problem at all. Okay, right, that's good. So this is soft, this is hard. That's why all the wear's in here, and there is a bit on here. You can see it and feel it, but it's nothing like as bad as what's in here. And we'll just try dropping that in there and indicating on this face here where the metal cover was for the rubber seal. So that's a nice machined face, and it's not had any wear because it's behind the that metal cover. I'll be using the boring head to machine out the damaged areas, and I'll machine both the top and the bottom out in one setup, and this will make sure that both of the sliding surfaces are concentric. I'm using a telescopic bore gauge and a micrometer to check that the part is to size. With the bottom bore cut to size, I could then move the tool in the boring head and then cut the top surface, maintaining concentricity. Just checking that the tool's going to go all the way through the part without hitting the bottom of the vise. Move the tool over now so that we can take the cut out of the bottom. Okay, it's a bit of a smaller hole, so let's bring the speed up a little bit. I'm using the auto feed on the quill to make sure that I get a nice consistent surface finish through the full depth of the cut. On the Bridgeport milling machine you can set a stop so that once the quill has travelled down to a set depth, it will disengage the feed. Tool looks alright. A quick deburr of the edges, and then we can have a look to see what the finish is like. Don't know if you can make it out, but it's just a hint of chatter there. Then it was over to the lathe to start making the sleeves. I started by telling the machine what diameter the material was, and then I could start removing the material until I got down to the desired size. I'm using a TNMG 16 carbide insert taking about 1.5mm depth of cut, which makes really quite nice chips on this machine. Once I was nearly at final size, I could do a quick measure and then take a final pass to get everything spot on. One final measure, this time with the micrometer, because it's just a little bit more accurate. Oh, there we go, 49 point, somewhere between 0.14 and 1.5. Okay, so we're within, 0.01, 0.02. That's plenty good enough.
I could then put a chamfer on the end and start drilling and boring out the centre. I'm using the telescopic bore gauge again here to check the inside diameter, and then with that at size I can part off. I gave that a quick clean up, and then I could set the whole thing up in the fly press to push the sleeve into the housing.
Oh, that's tight. Excellent. Perfect.
I could then go through the same steps again to make the sleeve for the small end, or the top. With both the sleeves pressed in, I now need to transfer the slot that holds the end of the spring into the larger of the two sleeves. So I set the part back up in the milling machine and clocked it in to make sure that the slot would be square. I could then change to an 8mm end mill and cut the slot, which is actually about 9mm. So I went down the centre and then just went out a little bit to each side to get it to the full width.
There we go.
I could then drill the hole for the grease point through the smaller of the two sleeves.
Just clear the threads out as well. So there's the grease porthole, and goes all the way through now to inject the grease into the sliding surface. Now there is what appears to be a boss for another grease port here, and it's the same on the other side that's not as worn out, but it's not been fitted at the factory. Now I'm reluctant to go drilling a grease port here, as much as I think it would benefit from one. There'll be a reason why they haven't done it. Now the reason could be somebody cocked up, or the machine wasn't set up correctly, or quality control missed it, or whatever. But it could equally be that they used to put the grease point in there, and then they had a load of these fail for some reason. My thought being, when this comes round and smacks against the stop, there's going to be a lot of radial force going around here, and having a hole really close to the edge could create some sort of stress concentration and maybe cause the part to crack. So I'm reluctant to drill that and tap it, and we'll just do a good job of putting the grease in here and push it all the way down. Right, let's fix this and this.
Over the years of use, the two faces that form the stop, where they've been hitting against each other, have progressively worn away. So I'm going to give those a good clean up and then build them back up with some weld and reshape them so that when the wing swings back into its home position, it's correctly aligned with the tyre beneath it. So that's those reshaped, and this is an ideal opportunity for a quick test just to make sure everything goes together before it's covered in grease and put together properly.
Oh, that feels good.
So I took it apart again, and it's now time to put it together for real. The first piece to go back is the metal shield that goes around the rubber seal. And then once that's in, the rubber seal can go in after it. Very carefully putting that in, because the metalwork is quite fragile and spares are not available for this. Then I could squirt a bit of grease around the sliding surfaces just to help with the reassembly. With that tap down, I could adjust the arm that connects to the fender and just line it up with the marks that I made earlier. And as you can see, I've already put the top cap and the screw in that holds the whole unit together.
That's that part finished. Now let's get on with the fender supports. The first job is to remove all the seized nuts. I just cut them down the centre with a slitting disc, then used a cold chisel to break them apart.
The fender supports themselves have got a few breaks in them that need welding up, so I need to take the fenders off so that I can get in with the welding torch to execute the repair. Now these have come from a livestock farm, so there was a certain amount of debris to remove before I could get in there with the grinder to clean up the weld areas. And I welded it all back together with the TIG. It was definitely quite thin in places.
So that's that one done. We've done repair across here, and then I've also just stitched this back together and round here, and then just put a little tack along the top here, and then this has got a bit of a weld across here too. So this one has already had this repair done at a previous time by somebody else, but what it needs is a new front making.
So I got out the ring roller that I made a couple of years ago, and there's a video of that if you're interested, and I rolled up some 25 by 50 box.
That is a pretty good match. So the ends are straight, so we'll cut the end off and then we'll have a short piece out of this, and I can always save this in case I ever need to do another one or do the other end or something.
I'm just using the steel rule as a straight edge to line the parts up. Then I could tack them together with the TIG welder.
I was going to reuse this bit, but it's not going to clean up nicely, and then it'll be a pain to weld and it'll be a bit thin. So we'll just make a new one.
I'm using some 3mm mild steel to make the new part. And I can just use the old one as a simple template to trace round. Then use the shear to trim off the corners before running over them with a file to get the radiuses on. Then it's back over to the welding bench to get that stuck on. And here's the repaired section all fully welded on. With that done, I could offer up the mudguard and mark the location for the screw holes. These stepped cutters really do make excellent deburring tools. I could then give the repaired areas a wipe down with some acetone to remove any grease, oil, dirt, and then a couple of coats of a zinc based rust inhibiting primer and a couple of coats of black paint to just help protect it from the rust. Time to put it all back together. I've got some new carriage bolts because we had to cut the old ones out to get everything apart. And I'm using nylock nuts on the underside because this is quite a high vibration area. And here are the repaired mudguards. Here they are back on the machine, and the customer is happy to have his machine back fully working. I hope you enjoyed the video. Please consider subscribing and sharing the video with anyone you think might be interested. Hopefully see you next time. Thanks for watching.